In this video, you're going to learn how to apply the information from what you learned about what the purpose of an ion, what the purpose of a molecule is. So how you're going to apply that information is by learning how to write chemical formulas. So steps for writing chemical formulas for monoatomic compounds. So remember, if it's monoatomic, it only has one ion. So first step, you're going to write the symbol for the metal first. Then you're going to write the symbol for the non-metal second. So you have to reflect back on your elements and your symbols. And remember, towards the left side of the periodic table lies your metals. Towards the right side of the periodic table lies your non-metals. Second step, identify the charge of the metal. Then identify the charge of the non-metal. So then if you think back to the oxidation or valence electron and octet rules that we talked about, the fact that you remember group 1, group 2 elements, their charges are what their group numbers are. Because all your metals are going to be cations, which means they're going to have a positive charge. Anything in group 1 or group 2 is going to have a +1 or a +2 charge. We'll talk about the transition metals later. And then groups 13 through 18, you're going to put a 1, you're going to remove the 1, and then what you're going to do is take what's left, and then you're going to subtract 8, and that's going to be your charge. So if it's in cation, then you would have a positive charge. If it's an anion, you're going to have a negative charge. So if we talk about boron, for example, boron is in group 13. You're going to remove the 1. 3 minus 8 gives you a -5 charge. But also remember, there are always exceptions to some of those rules. For example, aluminum. Aluminum is in the same family as boron, but aluminum will always have a +3 charge. So be careful. You have to remember to include our exceptions. Group number, valence electron number are the same. You're going to subtract 8. That's going to give you the charge. So with step 3, you're going to check and see if the charges are balanced already or not. So crisscross method, numerical charges if they're not equal to 0. Leave the actual charges. So what you're going to switch over are the numbers. So if sodium has a +1 charge and chlorine has a -1 charge, they're already balanced. So you won't have to do anything. But if sodium has a +1 charge and oxygen has a -2 charge, then you would use the crisscross method. Then you're going to check the math for a 0 balance. So you want to check to make sure that the number of atoms of each element is going to provide you with a positive and a negative number that are going to equal to 0. So now we're going to actually apply some of this process. So if you look here, for number 1 we have sodium. Remember, sodium is an alkali metal, so that's why it's red. You have no number here. Remember, if it's just a positive or negative sign, it's understood to be 1. Then you have fluorine. Fluorine is in group 17. You remove the 1. 7 minus 8 gives you a -1 charge, or you may just see a negative sign. A +1 and a -1 equal to 0. So what that's going to give you is 1 atom of sodium, 1 atom of fluorine, and then together you're going to have sodium fluoride, and it's just 1 atom of each. When you have 1 atom of each, you will not write the numbers in for the formula. So this is what the formula would actually look like. Problem 2, you have lithium. Lithium is also an alkali metal with a +1 charge. Bromine is a halogen. That's what this brown color is. Halogens are group 17. Remove the 1. 7 minus 8 gives you a -1. That's why you don't see anything here. Once again, we don't have the crisscross charges because +1 plus a -1 gives you 0. So that reduces down to Li1Br1, but when we write the formula, you'll just see LiBr. Problem 3, you have barium, which is Ba, and it has a 2+ charge because it's an alkali metal, and it's in group 2. Iodine is another halogen, so group 17, remove the 1, 7 minus 8 gives you a -1. So this is your first problem where you have 2 different charges. So you will use the crisscross method. So the 1 is going to carry from the iodine to the barium, and the 2 from the barium to the iodine. You reduce to Ba1I2, and this is going to be the formula here because the 1 is understood. BaI2. So now we have problem 4, which is going to be an alkali metal and oxygen family. So strontium, which is Sr, is also an alkali earth metal, and it's going to be in group 2. Oxygen has a -2 charge, and you get this -2 charge from the fact that it's in group 16. You remove the 1. 6 minus 8 gives you -2. A +2 and a -2 balance out to 0, so you just reduce SR1, O1 when you write the formula SRO. So now we're going to do application of polyatomic compounds. So remember, poly means more than one atom or multiple atoms. Typically, you can recognize a polyatomic compound if it has 3 capital letters in it. So, problem 1, you have Li, which is an alkali metal, group 1, +1 charge. Here you have another 2 capital letters, but this time this is your polyatomic ion. So this includes oxygen and hydrogen with a -1 charge. This is called hydroxide. So because hydroxide has a -1 charge, looking at a +1 charge, they already balance out to 0. You reduce down Li1, OH1. This gives you LiOH. So if you look here, you see 3 capital letters. That's a polyatomic compound. So number 2, you have Al, which is in the boron family. Remember, it's an exception, so it's a 3+ charge. This is a nitrate. Nitrate has a -1 charge. So aluminum 3+ with nitrate here with a -1 charge. Those charges don't balance out to be 0. So this is an opportunity for you to use the crisscross method. So aluminum has 3 will go to the nitrate, and the 1 from the nitrate will go to the aluminum. So now you actually have to use parentheses. These parentheses allow you to separate the 2 subscripts so that you don't think that this number would be 23, for example. So Al1 bracket NO2, because that's what a nitrate is. You close the bracket and you're going to put the 3 here. So this allows you to know that you're going to have 1 atom of aluminum, but for that 1 atom of aluminum, you're going to need 3 nitrates, which is an NO2, to balance it out. So when you reduce, you would remove the 1 because it's understood. You have Al bracket NO2 bracket 3. For number 3, you have Mg2+, and this thing called cyanide. Cyanide is Cn-, so cyanide has a -1 charge. Magnesium has a +2 charge. So you switch your charges, and then from there, you're going to see that magnesium is going to get the 1 from the cyanide. That's what you have here when you reduce down. The 2 is going to go to the cyanide over here. But to make sure that you understand that cyanide's formula is Cn and that you need more than 1 Cn, you use the bracket here. So Mg plus Cn is going to give you Mg1 bracket Cn1 bracket 2. You can reduce that to MgCN2. So now you should be able to go to worksheets 3 and 4 and practice some of this on your own.